We have a limited view of the stars. What we see in the gigantic expanses of the universe is by no means the big picture, but merely a section that is determined by a number of natural factors. But what is hidden in the part of the universe that is invisible to us? Is there even a way to crack this mystery? Well, there is, and the data collected suggests that there is something gigantic out there that has already stretched out its hidden arm towards our world. And the Earth is the center of the universe. But before you think that we have mentally strayed back to the Middle Ages, let us briefly explain what is meant by this. It should be clear to everyone that the geocentric view of the world, which places the Earth at the center of the cosmos, is long outdated. Nevertheless, our blue home planet is still the center of the observable universe, because, as already mentioned at the beginning, our view into the depths of space is blinkered against the background that the universe is isotropic. In other words, that it always presents itself to the observer. In the same way, regardless of the observer's direction of observation, there is a spherical space around our Earth that corresponds to our cosmic field of vision. The radius of the observable universe is in turn determined by how far light has been able to travel to us since the Big Bang, and since, according to the standard cosmological model, the universe was born around 13.8 billion years ago. You might think that the optical barrier is also 13.8 billion light-years away from us, but that's not true at this point. We must not forget that the universe has always been expanding, and that distances already traveled have been subsequently extended as a result. In plain language, this means that the observation horizon is not 13.8 but 46.3 billion light-years, and the most remote objects whose light we can observe today were just 40 million light-years away from Earth at the time they emitted that light. As a result, studying these boundary structures is always like optically traveling back in time, since the light that is currently emitted from there can no longer reach us. It's also impossible to learn anything about the current processes at this distance against this backdrop. The question of what lies beyond the observable universe seems doomed to failure from the outset. However, despite all observation, horizons, and natural barriers to vision, there are some experts who believe they have actually cracked this riddle. As a result, a few years ago, researchers became aware of a strange phenomenon that stands in stark contradiction to our current assumptions, and which could lead us straight to the deepest secrets of the invisible cosmos. Is there a cosmic giant hiding out there, basically, according to the common assumptions of cosmology? The proper motions of galaxy clusters, relative to the background radiation, should be randomly distributed in all directions. And once again, for a brief classification, the background radiation, or more precisely, the cosmic microwave background radiation, embodies a remnant of the period immediately following the Big Bang, which still permeates the entire universe today. NASA's Wilkinson Microwave Anisotropy Probe, also known as the WMAP, was once more tasked with examining anomalies in the cosmic background radiation. In 2008, while the NASA working group headed by Alexander Kashlinsky was examining the WMAP data, they observed an odd pattern that shouldn't have existed in this form. The scientists identified an incredibly uniform flow, rather than a movement, of galaxy clusters disperpendicated in all directions, and that's not all to all appearances. The galactic stream speed also increased with increasing distance. The conclusion is that an extreme gravitational force is the only thing that could cause this phenomenon. But what kind of structure could be to blame? Unfortunately, this question cannot be answered with absolute certainty, because all of the galaxy clusters under study are traveling in the direction of an object that is outside the observable universe, hence the term Kren dark flow. The galactic caravan was to be scrutinized again in 2010, with the result that the number of galaxy clusters floating along in the dark flow doubled from 700 to 1,400, although there were some differences in the direction of movement in the 4 observed segments. All areas showed a clear correspondence. Since then, astronomers have gained one more piece of evidence in favor of a massive structure with an extreme gravitational pole outside of the observable universe, and a tantalizing mystery, for while, according to Alexander Kashlinsky, there is no question that M matter in the observable universe cannot explain the measured galaxy flux, we do not know in the same breath what is really responsible for it. In this regard, the NASA astronomer from the Goddard Space Flight Center is quoted as follows: "We don't have enough information to see what it is, or to narrow it down. We can only say with certainty that the world somewhere far away is very different from what we see locally. Whether it is a different universe or a different space-time structure, we don't know." The dark flow critics of the dark flow theory ask whether we are dealing with the effects of strange space-time distortions brought on by the influence of a nearby universe, or whether our cosmic field of vision conceals an extreme accumulation of energy and matter that hopelessly surpasses all known orders of magnitude. The theory provides a definitive answer to these questions, but not for the simple reason that the leading researchers are alleged to have made some eyebrow-raising errors in this regard. A follow-up study concluded that the dark flow is not a physical phenomenon because the primary anisotropy, that is, the directional dependence of the cosmic background radiation, was disregarded in the previous study. Additionally, the analysis of over 550 super-NNOI revealed no impossible synchronous movement pattern, but rather behavior that is easily consistent with our cosmological models. Finally, the ESA Planck satellite data also yielded no evidence of a mysterious dark stream. A statistical coincidence can therefore be ruled out, and it's clear that the dark flow has not yet been definitively disproved, the question of what is behind it. And no matter what this may look like, if the originator of the dark flow really exists, this also means that there must inevitably be something behind our observable universe. And of course, Kaslinsky's researchers are neither the first nor the only ones to deal with the question of what this ominous behind might look like in detail. There is no need to emphasize at this point that dealing with this topic is always a matter of absolute speculation, and yet the corresponding theories are as different as they are astounding. And this is despite the fact that the first hypothesis sounds somewhat unspectacular. At first, it actually states that the invisible universe is structured in exactly the same way as the observable one. However, things become much more breathtaking if we transport this scenario into an infinite space, because then we will ultimately find all kinds of things, and by that we really mean all kinds of things. In this context, there is another solar system out there, complete with an Earth that is identical to ours in every respect, except that you may have had cornflakes instead of toast this morning. In another solar system, you may have skipped breakfast altogether, and in yet another, you got up this morning to rob a bank. According to some experts, there is an observable universe that is exactly like ours. In other words, there is a version of you in the infinite vastness of space that replicates every action you take. This idea may seem unthinkable at first, but infinity also offers an endless number of possibilities. Alternatively, according to Kaslinsky's hypothesis of an alternate universe, we might simply be in one of an endless number of cosmic bubbles. It is possible that most of the universe is expanding in an eternally inflationary fashion, with this process only stopping in certain bubble-shaped subareas. These sub-universes may each have its own natural constant values and, consequently, its own set of physical laws. In keeping with the motto, "Every world that is conceivable also exists," the multiverse concept of string theory holds that we only exist because there must be a world among the countless universes where the laws of physics are so perfectly coordinated that life can flourish. In detail, the concepts of string theory have now been further developed into membranes that have been broken down. The essence of the whole thing is that these 11th dimension ripple membranes embody completely different universes, and as soon as the ripples collide, they form a new cosmos. The idea that all of the gravity we experience in our universe is actually entering our world from another universe in a different dimension is one of the most bizarre aspects of this theory. Nevertheless, this theory may help to explain why gravity seems so weak here in comparison to the other fundamental forces of physics. If you would like our next video to appear on your homepage, pull your basic forces now and click the subscribe button. Join our community to ensure you never miss another thrilling video from us. See you soon.